Okay, hello everyone. Welcome back. Uh, so today we're going to be doing another demo, just continuing from what we did last time. But before I get into that, I just want to do some like groundkeeping. So today I'm going to be the only instructor here. Tony has a prelim, so he couldn't join us. But as of now, you all should be enrolled in the CMSX. If you aren't yet, just come see me after. I'll just manually add you. So the main three links in this class are going to be the CMSX, then the ed discussion, and then the course textbook. And then obviously when we post the recordings, YouTube. So those are going to be the main stuff for you guys for resources on how to complete the assignments. The first assignment will be going out tonight or soon, maybe tomorrow, and it will be due the following Monday. So sorry, 2 Mondays from now. So we're finishing up roots today, and then we have an optional Git lecture on Wednesday. You guys don't have to come to that. We won't be taking attendance, but if you want to learn more about Git and version control, you can come to that. And yeah, and then after we come back from break, we'll be resuming everything. So getting into the demo, if you guys remember from Monday, we went over the server client model. Basically, the client is the front end of the app, which is sending requests to the backend. The backend will process the requests, maybe go to a database, get some information, and then return it back to the front end. So today, we're going to be doing like development locally on our computer. So in this case, the client and the server are both going to be considered your laptop. In the real world, the client may be like an app on your phone, and the server might be some obscure server somewhere else in the world that you're connecting to. So for example, when you load up Google on your computer, you open the app on your computer, that's your client. It connects to a server at like the Google's database or whatever. That would be the server. So, but in this case, it's both going to be your computer. So let's just navigate back to where we were last demo. So if you guys remember from Monday or Wednesday, we used the terminal to navigate through our file system. So I'm just going to do a quick example of that. So if you're on Mac, you do Command Space, it'll pull up this window, or you can just type in anything, any application, open it. It'll be terminal for Mac, and then either Command Prompt or PowerShell for Windows. Let me open that. Right. So if you guys remember from before, since your laptop stores information in files called directories, we can simply change directories and find the source file that we downloaded from textbook. If you guys remember from last time, I stored mine in the desktop directory. You guys might have done the same, but I'll just show you a quick way of how to do that. So just starting off, does anyone remember the command for changing directories? Yes. CD, exactly. Literally change directory. So a quick way of listing all possible directories is ls, which means list. You can see all possible ones. Over here, we have applications, documents, IntelliJ projects. But the main one for me is going to be desktop. It might be different for you depending on where you download it. So using the command you just said, cd, and then we can just name the directory. So desktop. If you don't want to type the whole thing, you can hit tab and it'll autocomplete for you. So that's just a quick trick for how to get a faster terminal. And now that we're in the desktop directory, let's do ls just to see everything again. And I stored everything in this source file. So I'm going to change the directory into there as well. And then if you guys use Visual Studio Code, there's a shortcut you can use called code, which will literally just open up the Visual Studio app. And then the dot, which means the current directory. So I'm opening the current directory in Visual Studio. If you use Sublime or something else, there might be a shortcut for that. I'm not entirely sure, or you can just manually open it up in your file explorer. All right, can everyone see that? So these are the contents of my source folder. As you can see, source up here. Inside, we have an app.py, a requirements.txt, and a virtual environment, which is what we did last time. I'll just delete that just so we can all be on the same page if this is your first time. So another terminal command would be rm, which is remove -r means recursively. So it's going to delete every file within the directory I selected, and then venv, which is the name of the directory. So as you can see, it deleted the virtual environment directory. And the reason we use a virtual environment is to isolate our project basically from the rest of our Python system, just so we don't want any clutter or any random packages just floating around. So I'm gonna create a new virtual environment just to do that. Python 3. It may be Python for you if you don't have another version of Python installed. Do -m for module. So it is going to be running a module called virtual environment. And then this last command could be anything you want. Convention is to just name it venv. So I'm just going to do venv. And then it should run for a little bit, and then you'll see that venv directory pop up. Great. And then you can see down here, we notice a new environment. That's basically just registering that we created a new one. And now that we created the environment, we want to go ahead and activate it. On Mac, it's going to be dot, which is your current directory, venv, bin for binaries, and then activate. Then you'll see this little venv pop up. On Windows, I believe it's .venv scripts activate with a capital S. But then you should see this virtual environment pop up. And then we can install our dependencies that we need for this project, which are located in the requirements folder. You can use pip3 or pip install -r again for recursively, and then requirements.txt. And I just hit tab to autocomplete that. And then you should see a lot of lines of code that just says installing and collecting packages. So I'll just give you guys a little bit to do that, and then we can get started with the demo. Okay, so if you remember from last time, we have these two files, requirements.txt, which we just used, and then app.py. This is the main source of your project. This is going to be the file that we're running to run our server. So to actually run our server, we can just use Python to run this file. So Python 3, and then we just type in the file name. So app.py. You hit enter. You should see serving Flask app, debug mode on, this is a development server, whatever. And then to actually test to see if it's actually working, we can go to you can use command click to do that, but you can come up here and you can see hello world exactly as defined in our app.py over here. So this is our pretty bare bones app. It's just returning hello world, and this is what we're going to be working on today. And then a quick thing to point out, down here it says host 0, like that's where it's going to be hosting on. So if we go back to our Chrome right here, and we just copy and paste that, it's 0.0.0.0. And then we specify exactly which point we're listening in on. So 8,000. We'll get to the exact same page, which is exactly where our project is being hosted on. So to get more into the actual Flask syntax about how we're actually going to be creating routes, as Tony mentioned last class, basically the way a client, which in this case would be your laptop, connects to the server, which also in this case is your laptop. But generalizing this to like the outside world, if your phone wants to connect to google.com, what do? You type in google.com, right? In a similar way, to connect with our database, right, to connect with our server right now, we'll type in 0.0.0.0. Those are equivalent things in this sense. And so we can say that like whenever someone navigates to this route, they can grab this information and use it in their front end. And we can show that like this is the case because right now, if you see the highlighted here, it says app.root.slash, right? So if I go back to here, back to this, add a slash, it'll be the exact same page. Google just automatically formats it to take it out, but there is a slash there. And then to exemplify this even more, if I want to type like backend, right? So right now it's going to be serving hello world at the backend root. So now if I go back to my actual app and and I refresh the page, we see a not found error. That's because we're not actually serving anything at that root anymore. We're now serving at the /backend. So if I come up here, I do /backend, we now see it's been moved to /backend. So that's basically how the syntax works for Flask. You define a root, you define a method to go with that root, and then that's basically the method that's run every time someone goes to that specific root. In this case, it's /backend. And a cool thing about Flask is that you can see I don't have to rerun the server every time I make an edit. That's called a hot reload. A lot of frameworks don't have that, but it's especially useful now to just allow for easy development. So let's make this app more useful. So to begin, we're going to be covering databases in future sessions, but right now we'll just use a simple Python dictionary to store data. So to do that, basically, we're importing JSON. Basically, the entire web pretty much runs on 3 languages. It's HTML, CSS, and JavaScript. So how can we convert our Python code here into something that'll run on the web? We can use something called a JSON file, which is JavaScript object notation. It's basically exactly just like a Python dictionary with curly braces and key value pairs. So here we import JSON right here. And then obviously we're going to import something else from Flask. So from Flask, we're going to import requests. So what does that mean? When a client hits your URL, so in this case, /backend, they send a request. That could either be a GET request, a POST request, delete, patch. There's a lot of them, but those are going to be the main 4 that we cover in this class. When a client sends one of these requests, we need to have some way of processing this request because they might have sent some data along with it. And this is how we can access those requests and see the data inside. So that'll help us with actual requests. And now to make our app somewhat useful, we're just going to be doing a simple to-do app. So for each task, we'll have a description and something to indicate whether it's done or not. And then we're going to be representing it using Python dictionaries. So just some simple Python syntax. I'll just define a tasks dictionary. This is the syntax for an empty Python dictionary. And then every Python dictionary has a key value pair. In this case, I'm going to make the key like an ID of a task. So in this case, I'll index it at 0. So the very first task is going to have an ID of 0. So, and then within that, okay, that's GitHub Copilot if you guys have that downloaded. Within that, we can kind of like nest the dictionaries. So for that ID, we'll nest some more information in there. So again, these will take in key values. So an ID, which we will map to 0, is exactly the same here as before. We'll do a description. We'll map that to laundry. And then we'll have a done, which every task will start out with false. And then just for the sake of it, we'll just make 2 tasks. Make that ID 1. You can make the description like homework. And then the task right there is not done yet. So basically, we want every entry in here to be a unique ID. So that way we can access each one independently and have some way of tracking our tasks. So let's just add a counter right here. So task ID counter, we'll set that equal to 2. And that's just a simple integer variable declaration. So let's make this interesting. Let's first implement a route that gets all our current tasks. You can imagine this similar to what Instagram does, where when you're on Instagram, you want to get all the posts in your feed. So basically on Instagram, it'll go hit a database, grab all those, and then return those. Here, it's a little bit simpler. We have our task defined right here. We're going to get all of these and return them. So let's create a new route. So at app.route, basically, this is just Flask syntax. There's nothing really special about it. It's just how Flask wants things to be done. So let's just name that one tasks. And the key thing to keep in mind is that you preface this with a slash, meaning if you didn't have a slash here, so let's just use the backend one, for example. Let me comment that out. If we didn't have the backend one here, you'll see, well, there's a big error log, but basically it boils down to URLs must start with a leading slash, because what does that actually mean if you're trying to hit that root? That means you'd be trying to hit this, basically 0.0.0.0 backend, all in one word. That would be equivalent of being like going to google.com and then typing in backend at the very end, which is not what we want to do. So that's why we always preface it with a slash. So going back, I'll put the slash back in. I'll restart the server because that caused a crash. And then we'll actually implement our function to get all the tasks. So let's see, def. This is the function that's going to be run every time someone hits this link, it hits this root. So getTasks, and then tasks. And then we create a list of the actual task values. And then we're going to return that as a JSON, not a Python dictionary. Because right now, res, as you can probably tell, is a Python dictionary, and we want to convert that to a JSON. So we do json.dumps. This is just a built-in function in the module we imported, res, and then a special value here, 200. That basically tells you whoever sent the request, when the server returns a response, it tells you that the response was successful. Basically, anything in the 200 range is usually a good sign. Anything in the 400 range means the client is requesting something bad or something that doesn't exist. And something in the 500 range means something's wrong with the server. So right now we'll return a 200, which means okay, like it's good. And then we can save this file. Let's restart the server. And then we can go to our actual tasks backend. So 0.0.0.0 at port 8000/tasks. And now you can kind of see exactly what we wrote before, where it's tasks, and then we have a list of actual tasks. So the first one had an ID 0, description of laundry, and done equals false. And then you can see the second task right below it. So for the purposes of this class, the method name actually does not matter at all. So I can literally just call this name and it'll return the exact same thing. But just for clarity's sake and documentation, we should name them exactly what the purpose of the function is, just so that everyone's on the same page about it. So now we're going to do the same exact thing, but instead of returning all our tasks, we're going to want to create a new task. So basically right now, we only have 2 tasks, and let's say we want to add a new one. We have no way of doing that without rerunning the server and updating this task variable. So now what we want to do is have some way of the client being able to request or send a request and having this task update. So basically, they're sending us a new task to populate our database with. So we can create that. We can create that root right here. So again, app.root. This time, let's just name it. We'll name it the same exact thing. So basically, we're going to either send a get request to get all tasks or a post request to create a new task. And the way we can specify that is doing by comma methods, methods, and then equals. It takes an array of values. So post is one of them. If I wanted it to take a get, I do that, or I do this. So this way, this root would take both methods. But right now, we only want it to take post, which is basically when we want to create a new task. And then let's actually create the method to create a new task, which is we'll call createTask. And then we'll take the ID counter that we initialized before up here. That way we can make sure each one has a different ID. So to be able to reference it inside this, we need to declare it as a global variable. So that, and then body equals the request.data. Basically what this line is basically, remember how we imported this request library from before, where I said, this is how we get the data from the actual request. So when we send along a request to create a new task, we're going to be sending the task along with it, right? And that way we can, and through this, we can actually get all that data and reference it in a dictionary called body. So basically what JSON.loads does is it grabs all the data, converts it back to a dictionary so that we can use it in our Python file. And then we can make a description. Loads body.get description. And then we'll create a new task using this. So we have the ID, and then we're going to use that task ID counter that we just had before to keep everything like organized with different IDs. We're going to grab the actual description. And then we're going to make the done field always false, because whenever something's newly created, the task isn't done yet, it should always default to false. And then finally, we can insert it into our new dictionary. So basically what this does, it takes this and it inserts it into here. And then usually, first we have to increment the ID counter. And then usually when you create a new one, the response is always going to be the exact same thing, just sent back to you to symbolize that it's created. So we'll return the same thing before, json.dumps, task, and then 201. So usually, as I said before, 200 means it went well. 201 means it went well and something was successfully created in the database. So we can save that. And then as part of the pre-lecture downloads, you guys had to install something called Postman, which is just an app that we use to like hit endpoints on there and just simulate like a person going to it, but without actually doing it. So from here. So basically you don't need to create an account or anything. You can just skip forward to it and then come to this screen. So I'll give you guys a little bit to do that. Okay, so when you're here, since part of your assignments is going to be testing, and this is the way we're going to be testing like if your assignment is actually correct. So just to make things easier to do, we're going to create a new workspace. Basically, a workspace is just an overarching project file that just stores everything related to a project. So we can just create this one and call it backend course. And then within here, just going to delete everything else so it's easier to see. So we create our new workspace, and then we can add like individual requests within here. So let's create a new request. Basically, we'll just call this get all tasks. And what we want to do is basically exactly what we did before when we went to this route. And then you guys can see that it'll return the exact same thing. So we want our method set to get, and then we can just send this request, and we can see it returns exactly the same thing as it would if we went there through Chrome or something. The reason we use this is because we can change the actual method we use On Chrome, you can generally only do GET requests when you're using it through the browser. You can't send additional data, but with Postman, you can. And then you want to come here and set this to JSON just so it looks good, because we're going to be returning JSON files. Okay, so that's the actual get all task. Now we can use Postman to do a create a task. So I'll create a new request. I'll call this one. It doesn't really matter. Basically, we're going to be hitting the same exact route this time, but instead of a get, we're going to do a post, because remember in here, we defined our methods to be posts. By default, it says it means get. So you can omit that whenever it's a get, but every other time you have to use a post in the methods. And from here, we can see if I just simply send this with no additional information, we will get back an error. Basically, whenever you see HTML like this, you get basically an error. It says expecting value 1, line 1, column 1. Basically, what it's saying is the exact same thing in the terminal output. Basically, it's expecting information that we didn't provide it. So let's provide it some information. If you go to post and then you put it, usually you send information through requests in like one of two ways, either through the actual headers, which is like basically like authentication, like user, like the client, like the model of your computer, stuff like that. Or you can send it in the actual body, which is what we're going to be using. So going into the body, click raw just so we can type in our JSON input just like this. And then JSON is basically exactly the same as a Python dictionary. So you open your curly braces. It wants a description. So let's just provide a description. And then let's say the value of that is submit homework. So basically when we send this, we should be creating a new task that says submit homework. So let me restart the server. And then I'll send this. And you can see it was successful since we now have a new ID with the description submit homework and done equals false. And we can check this by going back to our get all task route. And then we hit send on this, and it'll provide us with the first one, which we implement ourselves, the second one, implement ourselves, and this third one, which we just created. So that's for getting all requests and creating a new request. Now, if we didn't want to get every request, but just a single one, the reason why we had each one have a distinct ID is because it'll be easier to reference now, so that we can easily get something by its ID. So we can go implement that now. So app.root, and then tasks. And then this is going to be a special syntax that I'll talk about after this. But basically what this means is we're going to this root tasks, and then there's going to be an integer after in the actual root that will be identified by this task ID object. So basically using this, we can do def like get task, and then we can provide the task ID there. So basically whenever this root is called with whatever number it is at the back, it'll pass it straight into this function, and then we can use that function to return the value. So we can do task equals task get task. And then if not task, this basically means this task ID doesn't exist in our database yet. So if I try to guess task ID like 10, there isn't a task for that, which means we don't want it to error out. So we'll just handle that by saying this. So return JSON dumps. And then we can pass in our own JSON file here, or Python dictionary here. So let's just say error, and then task not found. And then remember how I said 200s are usually for a status code of like something in the 200 range is for good stuff. 400 is for when the client tries to access something that isn't there or they're not authorized or something like that. And this is exactly that case where they're trying to get something that doesn't exist. So in this case, we return a special one. It's called 404 error. You guys have probably seen it. It means not found. So if there is a task, if there's not a task, we return this. But if there is, it'll continue on. Then we can just return JSON.dumps, the actual task that we got, and then 200. And then we can go ahead and test out this route. Let's create a new one. I'm just going to copy over this. And then, as we said before, when you put it in the parameter, when we define the special route where you have another slash and then a regular integer after. So to access that route, we can put like any integer here. I'm just going to do 1 here. And then we can go ahead and get that. Make sure you have the trailing and the prefix for these. Let me go ahead and run that again. And then you should see ID 1, description homework, done is false. And that's exactly the same one up here that we created. And now if we want to try to access something that doesn't exist, so let's say like 500, task ID 500, we can see error task not found. So this way we don't have the server itself like error out. And then we can also see over here in Postman 404 not found. So that's kind of a way for like front end to know that they're requesting like a bad resource. And now I think to keep in mind, remember how we created a new task and we gave it a new task ID of 2. So if we try to go access that now, we can see error not task not found. Basically what it's doing is, since we're running a Python file, there's only like one instance of this data and it's stored in this tasks variable. So every time we restart our Python script or restart the server, all that extra data that we created is now lost. So we'll have to create the new one again and then run this again. So we come back here. I'm just going to do the same exact thing. ID 2, description, submit homework. So that shows it created successfully. And then now when I try to get that by its ID, now it'll be there since we just created it and the new instance of task now has it. So that's one of the primary reasons why we want to use an external database. Over here, when we use a JSON or a Python dictionary, it's considered like volatile memory, meaning it'll be erased every time you restart it. Whereas a database will store those long-term. It's called persistent memory. So that's for getting tasks and creating a tasks. If we want to update a task, so that means, let's say we finish a task and we want to set the done thing to true in our to-do app. We can do that also by using a post request. So we can first define the new route, tasks. And then we also need to take in the integer of task ID. And then usually you can either use a couple different methods. In this class, we'll be using post. So the exact same thing as before, post. And then we can create the new route underneath. So dev update task. We take in that integer that we passed in here. So task ID. New task equals task get task ID. And then the same thing for the error handling. If it doesn't exist, then we just return. We can just copy and paste that. Otherwise, we want to get the new data that we want to update the task with. So we need to grab the actual like data from the request. So body equals JSON.loads, request.data. And then we set, since there's only two fields here, we can just set the description to the new description and the done field to the new done field that we passed in the request. So body.description, then tasks of done equals. And then we can simply return this new updated one that we just created. Sorry, this should be task, not tasks. And then while we're here, we'll also want to create like a delete task. So if we want to get rid of some stuff, app.root, and then /task / same thing. We grab the actual ID that we want to delete. And then this special method is actually called a delete method. So whenever you see this, you know to just delete the method. So def delete task, and then we take in the new task ID. Task equals basically it's very similar to this update one. So I'm just gonna copy and paste that in. And then instead of updating it here, we can use a special keyword called del, which basically allows you to delete a value in a JSON dictionary, in a Python dictionary. And then we provide the actual task ID. And then we'll return that one that we just deleted. That's just convention, just saying like this task has been successfully deleted. And then we can go ahead and test our routes. So there's going to be a post method. And so I'm just going to go ahead and update the first one. So I'm going to update the task with ID 1. Then we go to body. We put some raw JSON data in. So make description equal like new description. Then let's say done is now equal to true. And since we're passing in a Boolean value, we don't need it to be in string quotes. So we can send that over. I spelled something wrong. Sorry, here. Um, I'm sorry, which line were you saying? 51, 52. Okay. Oh, thank you. Yeah, that one S is just throwing everything off. So we can go ahead and send that. Sorry. Sorry. Yeah, I was treating it like, yeah, you can just reference it like this. I was treating it as a JSON object. That's my bad. But yeah, .get would work as well. Sorry about that. So now it does work. And we see that we've now updated the new description and done is true. So if we get all the tasks now, and I do it in like a pretty print, we can see that the second task or the ID task, the task with ID 1 is now updated. And then we can kind of do the same thing with delete. So if I wanted to delete that new task, I just come here, say delete, it'll return that. And then if I go back and get all tasks again, you can see that there's only now one task. And so now the final thing I want to cover is just documentation. So all of these routes, they're kind of self-explanatory. So you don't need a lot of documentation for this, but we will be looking for it, especially when the routes get more complicated. So the way you can do that is by doing 3 quotes, and that'll allow you to take like a doc string, and you can just say here returns all tasks. You can come here, pretty self-explanatory, but again, they are needed for like um, just readability wise. Create a new task. Then we can have here get a task by its ID. Have here date given its ID. And finally, delete a task given its ID. So yeah, that's about it for the demo. Finally, just to show you guys, you can export the entire thing and use that as part of, you'll have to submit that along with your assignment just to get credit for the assignment, so we know that you tested it. So you can come here, you click the 3 dots, and then you can see export. You come here to export. You want to export as v2.1, and then you export this, and you can submit that on CMSX with your assignment. So yeah, that was the demo. We can go into the quick Kahoot. So